everybody. I am your STEM tutor. Today we are looking at one aspect of mathematics. I mean STEM. We are looking at STEM in the field of mathematics. And we are going to one of the most interesting aspects of mathematics, which is factorization. Factorization, part 2. Part 1. We are start looking at factorization part 1. That part 1 has to do with the use of highest common factor, HCF, as a factor in the process of factorization. This topic is very wide and it cuts across various levels of education. But principally, it begins from junior secondary school 2, GSS2. Then you come across it in senior class, even down to university. Even there are some aspects of it that are also in advanced mathematics. So it's very important. So because it begins from a lower class, we have factorization part 1, which lays the foundation to subsequent parts of this particular topic. Now, like I said, we're looking at factorization part 1, and the part 1 has to do with using highest common factor, HCF, as a factor. Okay? Now, it is expected that before you tune into this particular class, you already know how to find HCF. It is assumed. So if not, you have to watch out for our video on how to find HCF of numbers, both normal number and algebraic terms numbers. Okay? So, let's start by looking at the meaning and real life. What do you mean by factorization? How is it applicable to you as a person in real life or in reality? Well, the meaning will bring out the real life application. Number 1, to factorize means to unravel onto simplicity. When you unravel a complex situation, you must not forget that as you go into the real world, into the workspace in the future, there are situations that you need to unravel. There are situations that you need to make very simple. There are tasks you need to deploy simplicity to be able to get them accomplished. So the knowledge of factorization build you up in that realm. To remove complexity, okay, something that is complex, when you factorize, you remove complexity. To cut through using a factor. You cut through situation by bringing out a factor. By looking into that situation, by looking at it from the perspective of factorization. To bring out a divisor or a common factor between or among entities or terms. It also means to sort out. You sort out a complex situation. Then, importantly, to differentiate. When you have 2 or 3 terms or entities, by the time you factor, then clearly you're able to see the differences. The differences are those things that remain as we use highest common factor in factorization. So we'll go to examples and clean this up. Don't forget the meaning and the varied application of factorization. Now, let's take some example now. Meanwhile, there are some problems, exercises you need to practice here. Okay, you have to practice the following exercise. The first one is you factorize the following, then you derive the formula for the following situation and then factorize them. There are situations I created. Number 1, curved surface area of a bucket or frustrum. Total surface area of a sealed cone. Then total surface area of a pie sealed at both ends. At the end of this expository, you should be able to answer this by yourself. So we have just 4 examples to use to buttress this and drive home our point. So number 1, factorize. Okay? Factorize 9n squared n minus 6mn. Factorize 9m squared n minus 6mn. If you ask to factorize this, they ask you to sort out a factor that is common to this term and this term. Like I said, the easier way, the method I want to deploy here is using highest common factor. So let's find the HCF first. HCF. That will be 9m squared n, then 6mn. Now, don't forget that when we say highest common factor, it means a factor that is highest. That means a factor that goes in these two entities at the same time. You cannot bring out a factor that does not go in the two others at the same time. So, what can go in 9 and that can go in 6? 3. How many times can 3 go in 9? 3 times. Remember that, okay? This one is letters, this one is also letter, okay? How many times can 3 goes in 6? 2, because 2 times 3 is 6. We have mn. If you look at this now, this is 3, this is 2. 3 cannot go in 2, neither can 2 go in 3 to remain, because we don't want anything remainder, okay? So it means you are done with number. Then let's look at the letter now. M is here, we have 2m here, okay? This is m raised to power 2. We have 1m here, so I pick 1m. What remains here, this is 3, bring down this 3. This m will cancel one of this m, it will remain 1m. Then this n is there. Okay, m in this m will cancel this, so we have 2n. Now we have m here, there is no m here again, so I can't use m again. So I'll go for n. There is 1n here, 1n here. So you have n. So if you use this to cut this, it will remain 3 and n. Use this to divide this, it will remain 2. Nothing can go again in this remainder at the same time. So it means that my HCF equals to this. This is my HCF. That will be 3 times m times n, which is 3mn. So therefore, factorize this thing now. This is the factor. This 3m will come out. Then you now open the bracket like this. Now, you see, when you use this one to divide this, that will be 9m squared n over 3mn. What will remain? What we will have as remainder is this 3m. Okay, 3 here 1, 3 here 3. This m cancel the 1, it will remain 1m here. This n cancel this n. You can see that what we have there is 3m. So that means the remainder here is the differences between these two terms. It brings out the differences. Do you see that? Minus what remains here? This 2. Meaning that if you use this HCF to divide this, what you have left is 2. Then you close the bracket. So it has been made simple. Before it was complex. Now it has been made simple. Simple because nothing can go inside the bracket again. That's our example 1. Okay? Right. Now, I hope that is clear. Very simple topic. We are not going to waste too much time on this. I will go to another example now. And that may be the end because it's straightforward. Very straightforward. Now look at this. Derive the curved surface area of a hunt below. A hunt. So there is a hunt given to us like this. You see the hunt. Okay, a touch roof hunt. Seal up. Now it has radius here. It has slant height. It has vertical height. Okay, then this is the height of the cylindrical part of the hunt, and this is the radius. Now look at this. You have to derive the curved surface area of a hunt below. You have to derive the curved surface area. Now, curved surface area is the area like this duster now. The curved surface area is this. Okay, I take it again. The curved surface area are this. Those are the curved surface area. Okay, the curved, the body parts. You can't take this because this one is not curved and this, but the one that surrounds it like this is the curved surface area. So if you look at this shape now, we have two solid shapes there. You can see a cone, then you can see a cylinder. So derive the curved surface area of the one below and factorize. That's the question. And factorize, okay? Okay. Now, so from this out, I can bring out these two. A cone. Now, for a cone, this one you need to know the formula. You have four-figure table. A cone, the curved surface area, the body surface of this cone is pi RL plus that of the cylinder, the part around it, that is 2 pi R-ish. That's it. That's the curved surface area of this particular shape. Now, they say you should factorize. We are using highest common factor method. That means we need to find the HCF, please bring it here, of this, and the HCF of this also, 2 pi R-ish. Okay? That because we are using highest common factor as the method. That means once I'm able to bring out the factor, which is common to these two terms, whatever remains will be the one that will now come inside the brackets. Is that clear? As we saw in the first example. So look at this. There is no number here except 1. This one, if there is no number, what is there is 1. Here is 2. So since there is no number here, and here is 2, you cannot use 2. So let's go for pi. There is pi here, there is pi here. So I pick one of the pi. This pi, you need to cancel this, it will remain RL. Okay? Use this to cancel this. Pi will go, it will remain 2 R and H. Now what can go again? This R is common again. So we pick R. If you use this to cancel this, it will remain L. Use this R to cancel this, it will remain 2 H. Can you see that? So that means our HCF is pi R, HCF equals to pi R. So that will be the factor we are looking for. Then open a bracket. What remains after you use this to divide this? It is L. You put L plus, if you use this to divide this, what remains is 2H. So put 2H. Then you close the bracket. So this is the derivation, and then this is the factorized form of it. Okay? So with this, we have come to the end of this particular class. So use that method to attempt all this. So please keep subscribing, sharing, supporting this particular platform as you look forward to factorization part 3. It actually go as far as factorization 6. You see, we build it up from junior secondary school, then into the advanced level. So you find it very enjoyable. Thank you very much. See you in another class.